How's it going, everybody? And welcome back to our Enterprise Practice Lab. And we're gonna, as promised from the previous three videos, we're gonna go ahead and set up all of our eBGP inter-ISP connections and then get all of our customer connections online and all that good stuff that goes along with it. So without any further ado, let's go up and pull up our PDF. Specifically, we're gonna focus on this stuff right here. So I'm just gonna go ahead, I know what needs to be done and where, I'm just gonna go ahead and do it. So let me go ahead and pull up Secure CRT. I'm going to get out of the way. And I'm going to start on the CSR side, so 28 to XR19. So CSR 28. And I'm going to go to router BGP 1, type in neighbor. And this is going to be 13.19.28.19. Type in remote AS is going to be 3, and then address family IPv4 unicast, and activate the peering. Oops. Just like that. Nothing more complicated than that. Now I'm going to go over to XR19 and show you the opposite direction. So I'm going to log in here, go to global config. I'm going to type in router BGP 1920. And I'm going to type in neighbor, and this was going to be 13.19.28.28, remote AS of 1, address family IPv4 unicast. Now what's going to end up happening is the peering will form with 28, and it usually takes a couple seconds for it to work, assuming that I've done my configuration at the interface level correctly. Do show IP interface brief. Do ping 13.19.28.19. It's a good sign. Patiently waiting for BGP to come online. So let's go back to XR19. Oh, no wonder it's not going to work. I first have to commit the config. Duh. All right, so full of surprises today, right? Okay, so the peering does come up. We see that right here, right? But it says no inbound IPv4 unicast policy and no outbound IPv4 unicast policy is defined. So if we were to do a do show BGP IPv4 unicast summary, what you get is this peering right here, right? The peering is up. On CSR 28, it's up. Show BGP IPv4 unicast summary. I have my peering up. But on XR side, on 19, notice this exclamation point. If I come in here and I do neighbor 13.19.28.28, and I look at configuration, if I go, where is it? The log message showed it. Can I go detail? Detail. Let's see. Is it going to tell me? Right here. eBGP neighbor with no inbound or outbound policy defaults to drop. So I need to create a route policy that's going to allow that connection to actually work. So what do I got to do? I'm going to type in route-policy, and I'm going to call this eBGP peers. I'm going to type in pass and exit out. That's all I need to do. I'm going to go back to show run router BGP, and then on that peering, so router BGP, in this case your 1920, underneath this peering, right? I'm going to type in route policy eBGP peers, and I'm going to say in and out. I'm going to go ahead and commit that config again, and then if I do show BGP IPv4 unicast summary, we have 5 learned routes. So if I hit the up arrow, I'm going to see 28's IP address. I'm learning a bunch of connections from it. It's a great sign, right? I'm going to do the exact same thing from 18 to 29, but I'm going to show run RPL, and I'm going to copy and paste this line of config. And I'm going to go over to XR18, because he's going to be the next peering that I need to set up. Go to global config, copy and paste that guy in. So I don't have to worry about it. Router BGP 1, neighbor of 13.18.29.29, remote AS of 3, and then address family IPv4 unicast, route policy eBGP peers in and out. Commit. I'm going to go to CSR29. I'll type in router BGP 19, or in this case here it's going to be 2930. Type in neighbor of 13.18.29.18, remote AS of 1, address family IPv4 unicast, and then I just have to activate the peering. Give that a moment to come online, and once it does, there it is, and do show IP BGP. So now I'm learning the routes in multiple ways, right? Which is exactly what I want to see. And remember I was telling you about how I would learn the ASN. So I'm learning the Confederation autonomous system number in from here. So I'm learning it this way. And if I go over to 30 and I do a show BGP IPv4 unicast, I'm learning, and this is where some additional BGP variations are going to come into play, but you're going to see that I'm learning the routes, but they're not, there's no greater than sign, they're not best routes, and the reason why is the next hop is not reachable. So there's a couple different ways that we can fix that, and I'll come back to that at a later point in time. Because if we do a show IP route, none of those routes are going to show up in the routing table, because they're not valid BGP routes. They're invalid. And if we were to look at them and look at, say for example, 1.16, the reason why they're invalid is because this IP address from CSR30, he doesn't know how to reach this IP right here. The IP address on gig02 on XR18, CSR30 has no idea what this IP is. And there's a couple of different ways to fix that. You can either take and add this subnet into OSPF so that OSPF can resolve it, or you simply tell CSR29 next hop self. Somehow this link right here has to get learned via OSPF in order for it to recur so the BGP can learn it, and if it does that, then you'll be in good shape. So we'll come back to that later though. So the next thing we're going to go do is we're going to go ahead and configure 39 and 40 to talk to 17 and 30. So XR17, I'm going to go ahead and log into him. Route-policy eBGP peers, pass, exit out, router BGP 1, neighbor of 12.17.39.39, remote AS of 2, address family IPv4 unicast, route-policy eBGP peers in and out. Commit that config. We're going to go over to 30, router BGP 2930, neighbor of 23.30.40.40, remote AS of 2, address family IPv4 unicast, activate. And then give that a moment or two, that'll come online. Well, we got to configure 39 and 40 yet. So 39, router BGP2, neighbor of 12.17.39.17, remote AS of 1, address family IPv4, activate, and 40. Router BGP 2, neighbor of 23.30.40.30, remote AS of 3, address family IPv4, activate. So give that a moment or so. We can see the peering is up that way, and 40 should get it as well. 40's up. Show BGP IPv4 unicast. So we're starting to learn a bunch of routes, which is good. So 40's learning it, and everything's looking pretty good. So we're getting that. If I go to CSR 16, show BGP IPv4 unicast, I'm seeing a bunch of stuff coming in the way that you would expect it to, which is awesome. Let's see here. CSR 30, again, is not liking it too much. Some things will be reachable, other stuff will not. So we scoot this up just a little bit. Remember how I said that 16, it won't be able to reach it? Well, it'll be able to reach it now because it knows how to get there through 40. So we'll eventually have to pick and choose, and this is, even though it's a ironically, even though this is a longer AS path, because this path it's not a valid route, it's going to choose the longer AS path because the shorter AS path doesn't have the right information. So now that we have that set up, let's go ahead and get some of our other connections squared away, and then we'll circle back to actually getting reachability into play. So the first thing we got to do is on 39. Where's CSR 39? It disappeared. Oh, it's right here. So CSR 39, I had to set up a peering on 2.39. So I'm going to type in neighbor, and it's going to be neighbor is going to be 2.39.0. In this case here, I'm going to use 111 because that's what we're using on 116. I'm going to type in remote AS of 65,001. Address family IPv4, and then activate. Right, that's just going to get the peering up, and then I'm also going to do a default dash information originate. Even though there's no default route yet, I don't have one configured yet anywhere or advertised into BGP, I'm going to configure it so that it passes the default route. So that's actually not going to come online because I don't have a connection up for it yet, and I'd have to log into Palo and set up BGP onto that. I'm not going to do that at the moment. I am going to go over to CSR 30 and go back to global config, and let me pull up my PDF here. So I'm going to scroll down to the spokes. So in CSR 32, I'm just going to create a default route to XRV20. So CSR 32, do show IP interface brief. I've got 3.2.32.32, so I'm going to type in IP route 0.0.0.0, 0.0.0.0 to 3.2.32.20, and that's it, all I have to do. So I just have a default route that I'm going to be advertising. I'm going to create interface loopback 1, IP address there would be 10.32.1.32, well in this case here it's a 1, but /24, loopback 2, and then loopback 3. So we have our /22 then allocated. So do show IP interface brief and do show IP route. Now I have a default route. If I ping 3.2.32.20, I should be able to ping it. Gig 2 on XR20. Show IP interface brief. Show IP interface brief. 2032 3 dot, yeah, 2032. Yeah, what have I got configured on CSR32? Show IP interface brief. Oh, interface gig 1 IP address of 3.20.32.32/24. Do show run pipe include IP route. No IP route this. And then we're going to add a 20. Do right. And so try to do that ping again. But this time do a 20. And the ping goes through. Okay, so the only thing I have to do now is on XRB20, which is right here, show run router BGP, is make sure that underneath the IPv4 unicast, right here, since I'm in this particular case, I have to do what they refer to as provider aggregated forwarding. So there's provider aggregated and provider independent. The difference between the two is provider aggregate means that the provider is advertising whatever public address block you have on your behalf. So a lot of customers, for example, residential internet, the service provider is going to advertise whatever subnet block you've got for you, so that you don't have to go in and form a BGP peering and then do network statements or whatever to the global table. Provider independent means that you own your own address space. You take a very small portion of that address space and you peer with the provider, and then you advertise the network statements from your equipment outbound to them. And then they configure prefix lists or filters to allow just what you're advertising to them and then out to the rest of the network. That's how that would come into play. In this particular case, since CSR32 is just a default route, then we're going to need, it's not going to have any way of, it's not going to configure thousands of static routes to reach everything on the internet. That doesn't make any sense. So we're going to go create a network statement in BGP underneath the address family to advertise the 3.20.32 subnet to BGP so everybody can reach it. So let's go ahead and do that real quick. So we're going to go to global config, router BGP, in this case here it's 1920. Type in address family IPv4 unicast. I'm going to type in network of 3.20.32.0/24. We're going to commit that command. And I'm going to look on, say, 29. Show BGP IPv4 unicast. And then momentarily, right there, I have it. 3.20.32, and it's reachable from 3.20.30, just like that. So now I have that. So now what I should be able to do is on, say, CSR39, which is right there. If I do a show BGP IPv4 unicast, I should see 3.20.32 via 23.30.40.30, which is coming via this peering right here. So that means, theoretically, I should be able to ping it. 3.20.32.32. Now, if I can't, this goes back to what I was talking about a little bit ago. It might have been, I can't remember if it's this video or the end of the last, that BGP control plane and data plane are two different things. I don't think I've actually discussed it in this level of detail, but essentially what's going to end up happening is the control plane of BGP is going to propagate the routes. However, in order for the data plane to work, all these devices here need to learn about all the routes. So oftentimes what ends up having to happen is I have to go and redistribute BGP into OSPF in order for OSPF to know how to recurse to whatever routes I'm looking at. So it's a redistribution of BGP into OSPF, so OSPF learns the routes and gets you where you got to go. Do service providers at the internet scale often use an IGP? Typically no. They're just going to do eBGP or confederations or something like that. It depends, but most service providers, they're going to have it set up to where they don't have to deal with this. And it'll be that much easier to get the job done when they don't have to worry about IGP. But some of them do, some of them don't. I don't do much ISP work anymore, so I know how I would fix it. So we can go in and make a couple of changes in a couple of different devices to make sure that the propagation happens. Control plane is there, data plane is not. Because if I was to look at, so on CSR 39 and be show IP route, if I look at 232, 232, 220, it's not in here, right? I don't see the subnet in here. That means that I got to get this route right here has to be learned internally in order for it to get propagated. Same thing with here. It's got to get learned in the data plane in order for it to learn it, and it's not there yet. So we'll take a look at exactly what that looks like. So let me give you an example of what I mean by that. Since I'm already on the topic, this will help eliminate a lot of other issues. But CSR 33 is going to form eBGP peerings to both, and then we're going to advertise our routes for them. So he owns his subnets. We're going to advertise them from 33. CSR 35 is going to do default route to 30, BGP to 40. So static route this way, BGP this way. And so on and so forth. But let me go ahead and minimize this, and we can focus on getting the data plane working so you guys can see what this looks like. So what I essentially need to do is on XR20 is redistribute this into OSPF, because if we look at say 29, let's take it a step closer. Let's go to 30. Let's start tracking her down, how far we have to go. So we're going to do a show IP route in the routing table. So let me scoot this up just a little bit so you can see it better. So we're looking for 230, right? And 30 doesn't see it. It would show up right about here. It doesn't see it. So if I do a show BGP IPv4 unicast though, I see it. Actually, it's not even not here yet. Oh, you know why? I'm sorry, it's 320. My bad. It's this one right here, and it is right here. It's being learned via iBGP. So I have it to 30. So I should be able to ping it then. Ping 3.20.32.32, and I can ping it from CSR 30. Okay, that's good. So what about 29? If I do unicast and I do a 3.20.32, I'm learning that from 3.20.30.20. That is XRV's peering IP. So that's actually, take that back. That is coming from, that's this peering right here, 20. This is the route that I'm learning it from, and I'm learning it from XRV20 via iBGP, as well as this one here. But they're both Confederation learned routes. But if I look at this particular prefix and look at it, the routes that are there, Confederation, one's Confed internal, one's Confed external. And if I look at the show IP route for 3.20.32, I see it as a BGP learned route there, which is good. So I'm going to ping 3.20.32.32. I can ping that from 29. Now let's take this a step further, and let's look at it from, I can bring this down just a little bit. Let's look at it from 40. Now on CSR 40, show IP or show BGP IPv4 unicast. Now 3.20.32 is showing up, and I'm learning that. If I do a show IP route, I see 3.20.32 coming in via BGP. If I ping 3.20.32.32, okay, that's a bad sign. So it's in my control plane. It's in my routing table. But when I look at it, I don't have a way of getting there. So let's go back up to here and let's look at the details of the subnet. Right? So I do have it. It's an eBGP external route. It's the best route, right? Now the drawback to it is, what about 23, 30, 23, 30, 40? What about that? If I go back to CSR 30, because it's directly connected, he's going to see that route. 23, 30, 40. But if I look at XRV 20, I jump out of global config and I do a show BGP IPv4 unicast. I see 23, 30, 30, 23, 30, 40. What about this? There's nothing here. I'm learning the route from two different ways, right? The problem is, though, it's coming from 23, 30, 40, 40, right here. But XRV 20 doesn't know how to reach that, right? So what we can do, there's two different things we can do. We can either do a network statement here to advertise this into BGP, or I can go into CSR 30, show run BGP or pipe section BGP, go to global config, and for the peering of 320, I can come down to here, 320, 30, 20, and I can come in here and say next hop self. Okay, now what that's going to do, when I do this, if I go back to XRB 20 and I hit the up arrow, it hasn't propagated yet because I need to clear it. So clear BGP IPv4 unicast star soft. Do this. Now I've changed the next hop to be CSR 30's loopback. Right? So if I come in here again and do that, and so now it's been able to clear the other route out, right? Now it sees it, right? So now that I've got that, let's go back to 40 and try pinging again. I can ping it because it knows how to reach it end to end. The route has to be in BGP in order for it to see whoever I'm connected to. XRV 20's got to be able to reach it. Now let's go back to 39 and do the same thing. Let's go in here, show BGP IPv4 unicast. 23, 30, 40 is in there. So what about 239, 40? 239, 40 is not here. So this would be a transit link, right? Now let's take a look at it from the perspective of XR20. What does XR20 see? Do I see a 239.40? Nope, I don't see a 239.40. It would be sitting right in here if I did. So what I got to do is on 39, which is way over here, I have to go and I have to propagate the route. So it's not already there. So what I can do is I can go to router BGP. In this case here it's going to be 2. Address family IPv4 unicast and type in network of 2.39.40.0 mask /24. Okay, now I'm advertising the route. Now if I go back to XRB 20, it might take a second for it to show up. But now if I look, I see a 239.40 going to 320, 30, 30. So now if I try to go back to 39, jump out of global config, try to ping again, I can ping it because now there's a transit link. So you have to advertise the routes into BGP or have it in OSPF so that the recursion can happen. So end to end now I'm good to go. So really the long story short, when it comes down to how routing propagation works, is BGP control plane, BGP data plane. The control plane can be programmed, right, and you can get propagation because you have the peering. The BGP updates come in, the BGP updates are propagated as long as you have a control plane peering. If the peering is there, but the underlying network doesn't know how to find where you're trying to point from, so wherever the remote end is, if this side here is connected and this side here is connected, but the stuff in the middle doesn't know how to reach it, that's going to be a bad sign. So normally what will end up happening is all these connected routes in the middle, you're just going to do something like a redistribute connected or network statements for that. So let's go ahead and just knock that out real quick. On here, I'm going to go to router BGP 2, address family IPv4, and then network of 2.39.75.0 mask /24. Simple as that. Now if I go back over here to XRB20 and I hit the up arrow, I should see now once it propagates 239, it's not there yet. It usually takes a moment or two for it to come across. But once it does, we'll see that subnet in the 74, not 75. That's my mistake. That's supposed to be 40 is 75, so that's my mistake. So let's go, because it can't advertise something it doesn't own. Hit the up arrow. 239.74. Now, in this particular case, because I'm advertising it from CSR39, it's being learned via, it's originating in AS2, but being learned by AS1 first. And if we look, hit arrow again, because now it's converged, it's now seeing it via 320.30 as it should, and it's going through the path that it needs to. So let me just make sure that I'm looking at right. 2030. Yeah, it's coming across this way. So the propagation is happening the way you want it to. So this would be a great example of XRB20 is learning it this way, right? But a moment ago, it was learning 239.74 from 13.19.28.28. Now, that's this path right here. So let me ask you this question. We ran into that exact same problem right here, right? So how do we fix this problem? Next top self, right? Well, what about this one? Well, what we can do, I believe on CSR28, I'll double check the config. Show run pipe section BGP. I advertise this subnet into BGP, right? Now the problem with that on XRB20 is that I don't know how, let me look at this, I don't know how to get to this IP address. Even though I advertised it, it's still being learned, I don't know how to get there. XRB20 doesn't have a route to this IP address, right? Now I can configure a static route and point to the next hop of XR19, but it makes more sense on XR19 to come in here and go to global config and type in router BGP 1920 and then type in neighbor of 3.0.0.20, address family IPv4 unicast, and type in next hop self. That's what I prefer doing. Okay, now XRB20 is going to learn that route again. And now it might take some time to get updated. If I look at this guy right here, you're gonna see it advertised from 19 and from 30. I'm waiting for it to finish propagating, so we should see the it should be coming across. So here's one of the things that's cool about the connectivity. If we were to do a from CSR, look at XRB19, do a show BGP IPv4 unicast, we're learning 239.74 from in this particular case here, I'm learning 239.74 from 13.18.29.18. Right, 18 and 13.19.28.28. So this path and this path here, right? The problem is that if we were to look at this output, right? The problem that we're going to run into, if we look at these from 19's perspective, the one directly connected peering is it's an eBGP path, but from CSR 28's perspective, which is right here, show BGP IPv4 unicast, the route is in the routing table, and it's a route reflector client. So propagation wise, it should be working the way we expect it to. Let me go to the 17 and see what 17 sees. Show BGP IPv4 unicast. So I see 239.74 coming from 12.17.39.39. That's the way I should see it. He sends that to CSR 28. CSR 28 sees it coming in from 13.19.28.19. So what's funny about that is, even though I'm seeing it from 17, he's learning it from XR 19 and 17 respectively, because we have 13, 19, 28, 19. We have this peering right here. We're learning that route in that way. 12, 17, 39, 39. But what's interesting about it is when we look at the specific route, 24, it's a route reflector client. Unfortunately, the update is coming across, but when we look at XR19 and that same prefix, right? Let's look at this. If we look at it, it's learning it that way. So theoretically speaking, with everything that we have set up, XRB20 should see it come in multiple ways. So let me look at the neighbor of 3.0.0.19 and look at, let's say, received routes. Received routes. So it's going to tell me that I don't have soft reconfiguration inbound applied. But if I was to look at the opposite way and type in show BGP unicast neighbors 3.0.0.20 advertise routes, I'm going to see that it's not advertising that subnet. It's got it, but it's not advertising that subnet. It's not sending it. That's why. I'm learning it from 29 and from 28. So I am learning it from 28, but I'm not advertising it to outbound to 20. So what I can do is show run router BGP, and on that peering to 19, soft address family IPv4 unicast, soft reconfiguration inbound always. Commit that config, jump back down here, and then I can do receive routes. I'm not receiving it inbound. So this is pre-table, right? But if I look at, and I suppose that's okay. It doesn't really make a difference. I'm not sure why I'm spending so much time on trying to narrow that down. Things get interesting when you do confederations, but at the end of the day, it should still theoretically work. So let's go ahead and get the remaining peerings in place, get the network statements in that we need so that we can get the rest of this configuration done so that we're squared away. So let's go over here to the Nexus switches. Let's jump over CSR 40. Show run pipe section BGP. So we've got 4075 router BGP 2 address family IPv4 unicast network of 2.40.75.0 mask /24. And that should be sufficient. So now XRB20, let's bring this guy back over a little bit. XRB20 should start seeing $240 showing up, which he does, coming from 2030, which is probably the better way of seeing it because it's one less AS path. So that's good. And then 74 and 75. I'll get those. I'll do 74. He'll advertise the subnet in. As long as it's reachability, that's really all that matters. Show BGP IPv4 unicast. And we're going to see a lot of routes. We're going to go ahead and type in router BGP 2 address family IPv4 unicast and a network of 2.74.75.0/24. And then XRB20 should learn that as well. 7475 via 203030. Perfect. That's exactly what you'd expect to see. So now that I've got that all squared away, the next one to go do would be to pull this back up here. We're going to go and configure, let's get 33 knocked out since we're right here. 33. That's going to be eBGP peerings to ISP 2 and 3. So on here, I'm going to do router BGP 65033. No BGP, and I'm going to keep the BGP config vanilla. I'm going to type in network neighbor of 3.20.33.20 remote AS of 3, and then neighbor of 3.20.30.3 remote. Oh, I made a mistake. I thought it was both ASs, but that's okay. Remote AS. I can't do the local device, so it's got to be 30. Remote AS. Remote AS of 3. Address family IPv4 unicast. And then I'm going to say network of 3.20.33.0 mask /24 and 30 respectively. And then do show IP interface brief, interface loopback 1, IP address here will be 10.33.1.1, and then loopback 2, we'll do 2, and then loopback 3, we'll get 3. So save that config the way it is, and then XRB20 global config router BGP 1920 neighbor of 3.20.33.33 remote AS 65033 address family IPv4 unicast, and then we'll do a route dash policy of eBGP peers. Do I not have that set up yet? eBGP underscore peers in and out. So let's go ahead and route dash policy eBGP peers pass exit commit. That should get a peering on 33 here momentarily. I won't do the same thing on 30. Router BGP 3, or in this case here 2930. Neighbor of, and that worked, 3.30.33.33 remote AS of 65033, and then that's all I need. And then I don't need to do address family IPv4. Sometimes I've got too many configuration variations going on. I forget which box is running which. So there we have that. So that should come up momentarily. Do show IP interface brief. .33. Not sure why that hasn't come up yet. Do ping 3.30.33.33. Do show run section BGP. Let's check 33's config. Do show run section BGP. Oh, my mistake. Make this a 30 and make this a 30. Oh wait, I screwed up. Whoopsie. I need to have, so that one's good, and then I need to go create this one again. There we go. Show BGP IPv4 unicast. Now I'm going to receive a bunch of routes. So I should have a bunch of routes to everything else, which is what I want. I'm going to save that config again. And then 35. We're going to do show IP interface brief on 35 to CSR 30. 3.30.35.30. So do ping 3.30.35.30. And then IP route, just the default, to 3.30.35.30. And then we're going to do router BGP 65035, neighbor of 3.30.35.30, remote AS of 3. And on 30, neighbor of 3.30.35.35, remote AS 65035, and then activate the peering. Perfect. And then if I go back to CSR 35, show IP route, I'm having a static default in the table, but if I look at the show BGP IPv4 unicast, BGP is still trying to figure itself out at the moment. Once it does, we'll be in good shape, because right now it's basically saying I don't know how to get anywhere. If you're missing the greater than sign right here, on any of these routes, that's a bad sign. Because then they're valid routes with the star, they're just not best routes with the exclamation. So once it figures itself out, then it should be able to go ahead and move forward. So I'm not too worried about it, and as soon as these routes right here are good, then they'll show up in the routing table. Until that, nothing's going to happen. So we're good to go there. Now in CSR 30, let's jump out of here and do a show BGP IPv4 unicast. And we have a lot of best routes, right? There they are. It took BGP a minute, but now all those more specific routes show up. I'm going to go ahead and go to global config. Let's see, advertise the local subnets 30. What am I advertising from 30? Show run section BGP. Am I advertising the local subnets? I am not. So I need to go on to 35 and router BGP 65035 address family network of 3.30.35.0 mask /24. This would be an example of provider independent network routing. And oh, hold on a second. I made a mistake. 35 is supposed to appear to CSR 40. My bad. That's what happens when you have this pulled up here. That's okay though. I still need to advertise the subnets. 3.35.40.0 mask /24. And then I'm gonna say do show run section BGP, and I'm gonna say no neighbor to this guy, because I already have a default route there. So that's gonna take the peering down. And then on 30, I'll take the peering down here as well. Show run section BGP, and then I will come in here and this guy right here. Make sure I've got, there's a lot of config now. Grab this guy right here. Actually, I can grab it from right here. Just these few lines. I'll copy and paste this into BGP, and then I'll say no there. That'll remove the config. And then I'll go bring this down just a little bit. And on 40, just way over here, router BGP2 neighbor of 2.35.40.35 remote AS of 65035, and then that's do show run section BGP address family IPv4. Well, I go ahead and activate it, save the config, and then on 35, neighbor of 2.35.40.40 remote AS of 2. So give it a moment and we should have a peering up to him. Assuming I've done my job correctly. Okay, so 35, do show IP interface brief. Gig 2, oh, I've got the wrong IP. So interface gig 2, IP address is 2.35.40.35/24. My mistake. There it goes. and then we're going to do interface loopback 1. IP address is going to be 10.35.1.1/24. Loopback 2. And then loopback 3. And I'm going to go ahead and save that config. So that gets that up. CSR 45 is going to be our provider edge. We'll talk about MPLS at a later point in time. So 36, since we're this close, and we only have 31, 34 left, and the firewalls. So I'm actually going to come back to these guys. I'll get the peering in 31, and I'll finish the peerings here, because that'll allow us to do DMVPN. I'll do the ones that are going to MPLS, that'll be done at a different point in time, and I'll come back to the firewall in a different video, because we're already at an hour. So let me go ahead and 36, we're going to peer to Nexus 75, router BGP 65036. We're going to do neighbor do show IP interface brief. Do ping 2.36.75.75. Make sure I can ping it. And then we're going to do neighbor of 36.75.75 remote AS of 2. And then advertise local subnet via BGP network of 2.36.75.0 mask/24. When you start seeing this means that Nexus is not configured on the remote side. It'll continue to do this until we configure Nexus. So Nexus, admin and admin, she'll run BGP. We're going to go to global config, router BGP 2, neighbor of 2.36.75.36, remote AS of 65036, address family IPv4, unicast. Give that a moment to come online. And 36 is up. Perfect. So do show IP BGP. We're seeing a bunch of routes, which is good. And then we're going to go ahead and do show IP interface brief. Interface loopback 1. IP address there will be 10.36.1.1/24. Loopback 2. And then loopback 3. Just like that. Do right. Okay, now that that's done, we're in pretty good shape. The last two we have a couple more to do. We're gonna go do we have to do connection 31 to 17. So let's go back this way. So we get XR17. Get him online. Router BGP 1. We're going to do show IP interface brief. Do ping 1.17.31.31. Make sure I can ping it. That's a good sign. And then we're going to do neighbor of 1.17.31.31. Remote AS of 65001. And then address family IPv4 unicast. Route dash policy eBGP underscore peers in and out. And then we're going to go ahead and That's all we have to do, and commit that config. So that one's completed. And then we have to do 31 to, let's go to 31, get this site configured. Do show run, I don't think there's BGP on there yet. BGP, no. Router BGP 65001, no BGP, default IPv4, neighbor of 1.17.31.17, remote AS of 1, address family IPv4, and then activate that peering. And then we're going to do another neighbor to 2.30, actually let's do ping 2.31.74.74, neighbor of 2.31.74.74, remote AS of 2, address family IPv4, activate that peering, and then we're going to leave off the other one to the MPLS. I'm going to go ahead and just save that config here. I'm going to go to 34. 34 and get him configured real quick. Do ping 2.34.39.39. Make sure I can ping. I can. Router BGP 65001. No BGP default IPv4. Neighbor of 2.34.39.39. Remote AS of 2. Address family IPv4. Activate. And then we're going to save that config on that guy. I'm going to jump over to 39 since he's right here. Get him configured. Router BGP 2. Neighbor 2.34.39.34. Remote AS is 65001. And activate the address family. There it goes. Do right, save that config, and I'm going to jump over to 74 and get him squared away. So neighbor of 2.31.74.31, remote AS of 65,001, address family IPv4 unicast. And then on 31, we should have a BGP peering here show up here momentarily. There we go. Show BGP IPv4 unicast. And I'm learning a bunch of routes. Perfect. So I'm learning everything that I want to learn. That's exactly how I want it to look. So I'm going to go ahead and save that config. So with that being said, that's all of the connectivity that we needed to have in play. We have all of our eBGP peering set up. We have all of our to enter ISP and then downstream to our service provider or our customer sites. With all of that in play now, we'll be able to then look at things like DMVPN and stuff like that. I'm going to hold off on that until I get MPLS up. And then MPLS is in here somewhere. Yeah, it's right here. MPLS is right here. So it's going to be a pretty straightforward config for MPLS. I'll walk you through the config in that. That's going to be its own dedicated video. And then we'll probably focus on getting eBGP peerings to where we got to go. And we're going to have a little bit of fun on 36 to get that working. But nonetheless, it'll be a pretty good lab to get all that type of stuff squared away. So we're almost there. And then once we get MPLS up and running, and then we get all of our peerings up and running to that, then we'll be able to do DMVPN to all of our spokes and get that up, do a dual hub. And then my plan is to start getting the colo sites operational, stand them up, and they'll be in good shape. So just out of curiosity, what are we at status-wise? 27% memory, 16% CPU with 65 nodes. So I'm going to be adding another 1, 2, 3, 4, 5, 6, 12. So 12 and 65, it'll be 77 by the time I'm done. probably the biggest lab I've ever built. So, but having a lot of fun doing it, as you can tell. And then we got to do Palo to set up HA, and then set up the BGP peering from here out to CSR 39. That's its own video as well, just to make sure that everything's working the way we want it to, and we can get failover to work and all that good stuff. Until next time, guys. Thanks so much for stopping by and hanging out with me, and I'll catch all of you in the next video.